Hello everyone, welcome to the channel Unshackling Sudokus and Puzzles. Hope all of you have been doing good, and today we are going to solve a classic Sudoku created by Kumar, who has been contributing some excellent Sudokus recently. Kumar is a wonderful Sudoku author and he has contributed to many contests in Logic Masters India, including Sudoku Mahabharat and a recent monthly contest as well. He has also contributed to offline championships like Asian Sudoku Championship that was held earlier this year in Hyderabad. So during the course of this video, we will be explaining XYZ Wing. We are sure that after watching the video, you will definitely become stronger at spotting XYZ wings because we have included multiple examples in this video. So having said that, we will move on to the rules. The rules are standard and simple. Each row, each column and each box of the 3x3 grid will have, of the 9x9 grid will have digits from 1 to 9 without any repetitions. So let us start solving the classic Sudoku now. So we'll look for simple digits that we can place without any effort. So if you look at box 1, let me change it to number mode. So if you look at box 1, 7 can't be in these two cells and 7 cannot be here. So 7 would have to go here, right? So this has to be a 7. So remaining digits in this box are 3, 6 and 8. So 6 and 8 are not possible in row 2. So this will be a 3 and these two cells must be 6 and 8. Now let us look at the exact symmetric box to box 1 and to see if we can place some more digits. 1, 2, 3, 4, 5 are givens. Remaining are 6, 7, 8 and 9. But you can't have 7 and 9 in these two cells, which means we can lock a pair into these two cells, 7, 9. And these two cells must be 6, 8, right? Oh, we can easily resolve them immediately. You have a 7 here, so this must be a 9 and this must be a 7. And you also have an 8 in column 8, so which means this must be 6 and this must be 8. Clear? So in row 9, 6, 7, 8, 3, 4, 9 are filled. The remaining digits are 1, 2 and 5. You have a 5 here, so this is 1 and 2. This is 1, 2, 5 and this is 1, 2 and 5. So where do we focus on now? There is a 5 in column 6 and column 5, which means 5 in box 8 must go into one of these two cells. But 5 is in row 7, so we can eliminate the 5 from here. So this must be a 5, which means 5 must be in one of these two cells. Okay. And there is a 5 in row 1 and row 3, which means 5 in box 3 must be in one of these two cells. But 5 is here, so this is not a 5 and this must be a 5. Great. So let us focus on this row now because we have got 6 digits. In Sudokus, it always is easier to solve when you focus on areas which have a lot of digits already. So this row particularly has 6 digits. So remaining digits in this row are 1, 2 and 4, right? 3, 6, 7, 9, 5, 8. So 4 is here, so this must be 1 and 2. This must be 1, 2, 4 and this must be a 1, 2 or a 4. So there is a 1 in not possible in these three cells because of this 1, which means 1 must go into one of these two cells. So why don't we make a corner pencil mark? So 1 must be in one of these two cells, which means we can eliminate the 1 from this cell, right? So this must be 2 or 4. Where do we go now? So let us look at row 8 because it has 6 digits filled. 5, 7, 9, 2, 6, 8. So remaining digits are 1, 3 and 4. But 1 is in column 1. So this is 3, 4. This is 1, 3, 4 and this is going to be 1, 3 and 4. Right? No more digits are possible. Let us look at row 1 now. 5 digits are there and this box also has a 8. So potential for elimination is more. So 1, 2, 5, 7, 9 and 8 are not possible in these two cells. So these two cells must be 3, 4, 6 and 3, 4, 6. But you have a 3, 6 in column 8. So this must be a 4. Superb. So we got a 4 here. So this must be a 3 or a 6. And this cell must be 3, 6 or 8. But 6 is here. So this must be 3 or 8. Okay. So 5 is in column 7 and column 9. So 5 in column 8 must go into one of these two cells because of this 5. Okay, let us look at row 5 because it's completely empty in 4 cells and we have got some column digits, so it might help. 3, 5, 6, 7 and 8 are placed. Remaining digits are 1, 2, 4 and 9. So you have a 2 here, this must be 1, 4, 9, and you have a 4, 9 here, this is 1, 2, and this cannot be 1, 2 and 9, so this must be a 4. Great. And this must be 1, 2 or 9, right? This must be 1, 2 or 9. So you can eliminate the 4 from here, this is 1 or a 9. And let us look at column 9 now. 4, 5, 8, 3 and 9. Remaining digits are 1, 2, 6 and 7. But in all these 3 cells, we can't make any elimination, right? 1, 2, 6, 7 are all possible, so we'll leave that for now. So in Sudokus, I normally don't tend to write candidates in cells when they exceed 3 or more. Unless or otherwise they become extremely hard to solve. You can restrict any classic Sudoku, any human constructed classic Sudoku to only 3 possibilities in a cell. So let us look at column 1. 1, 5, 7, 6, 8. Remaining digits are 2, 3, 4, 9. Your 9 is here, so this is 2, 3, 4. So 9 must be in one of these 2 cells. Both these cells have 4 candidates. So let us restrict writing the digits for now. So column 5 also has 4 candidates possible. Oh, this cell. 5, 6, 7, 8 and 9 are not possible. So this cell must be 1, 2, 3 or 4. But 4 is here. So this is 1, 2 and 3. And these cells are all, okay, this can't be 1. So this is 2, 3, 4. So you can have 1, 2, 3, 4 in both of these cells. So nothing there. Let us look at column 7 to see if we can get some more eliminations. You have an 8 in column 8 and 9, so which means 8 must be in one of these 2 cells. This could have been placed earlier also. So 8 is here, right? So can we place some more 8s? You have 8 here, you have 8 here, so which means 8 must be in one of these 2 cells, right? And remaining digits in column 7 are 3, 6, 7. So we can candidate them. So 3, 6 and 7. Any eliminations? No more eliminations. So, and 2 is here, so we can eliminate the 2 from here. So this is 1 or 5, right? Simple. So let us, okay, 1 is restricted to one of these 2 cells, right? So which means we can eliminate the 1 from here. So this is not going to be 5, 6, 7, 8, 9 or 1. So this can only be 2, 3 or 4. So we have a quadruple, right? 2, 4, 2, 3, 4, 1, 3, 4 and 1 and 2. Wait. There is a simpler way to place the 9. You can just simply place the 9 instead of looking at this quadruple. However, we know that the only possible digit left in this cell is now a 6 because these 4 cells will contain 1, 2, 3, 4 in some order. So we'll remove the corner pencil mark 1 from those cells. They are not required. And now this cell can't be a 1, can't be 5, 6, 9, 7 and 8. So this can only be 2, 3 or 4. So which means that 8 and 9 will be restricted to these 3 cells in this row. Any box reduction? No. No more simple eliminations. Right. So we have reached the point where we are going to use the XYZ wings. So I'll be explaining the XYZ wing with the help of some multiple examples so that they are easier to spot for our viewers. So if you look at XYZ wing, how they work is you must have a cell which has a possibility of the form X and Y, and then you will have a cell of the form XYZ, and then you will have a cell of the form YZ. And for the XYZ wing to work, you need these 3 cells to be in different boxes, different rows and different columns. So for example, you cannot have XYZ wing obviously within the same row, same column or same box. So these 2 cells must be distributed exactly across 2 different rows, 2 different columns or 2 different boxes. So here we have seen that they are distributed across 2 different columns or 2 different boxes as well. So when you have such a formation, right, XY, XYZ and YZ, right? So this candidate by wiki terminology is called the hinge candidate or the apex candidate, right? It must have exactly 3 possibilities and the other 2 cells must have exactly 2 possibilities with 1 cell in common. So if you look at these 2 cells, which is seen by the hinge candidate which is having exactly 3 cells, so this cell has exactly 1 digit in common. So for the XYZ wing to work, you must have exactly 3 different cells across two different rows, boxes or columns, and the hinge candidate must have 3 candidates exactly, and the other 2 cells must have 2 possibilities exactly with 1 possibility in common. So when you have such a scenario, these 2 cells can't contain the digit which is common between these cells. So by that I mean you can't have a y in this cell. Sorry, you can't have a y in this cell. Why is that the case? So let us imagine that we have a y here, right? So when you have a y here, so this cell becomes an x and this cell becomes a z. Now what can you have in this cell? You can't have anything, right? Similarly, a y here leads to the exact same scenario. So this is how an XYZ wing works. So to simplify it in words, when you have such a formation, right, you can eliminate the common candidate between these 2 cells from the cells which see all the 3 cells. So you see that these are the 3 cells and these 2 cells see all the 3 cells, and you can eliminate the common candidate between these cells from these 2 cells. So this is how an XYZ wing works, and we have an example shown here immediately. You see that we have a hinge candidate which is having 3 candidates exactly and 2 other cells which are having exactly 1 digit in common. Now how the XYZ wing works is that from these 2 cells which is seeing all the 3 cells, we can eliminate the common candidate. So you basically can't have a 2 in this cell or this cell. So why is it the case? So if you have a 2 here, let's say you have a 2 here, this becomes a 5 and this becomes a 1. So what will you have here? Nothing, right? So this is how XYZ wings work. They are always wonderful to see if you know what exactly to look for, right? Similarly, if you have a 2 here, you get a 5 here, a 1 here, and you can't have anything here. So for any XYZ wings, basically you will have only 2 cells which see all the 3 cells. This works for any XYZ wing. So we will move on to another example now, so that our viewers get a perfect idea of how an XYZ wing works. So here I have added an additional possibility to to show how exactly it works. So we have a candidate of the form XY here, we have the candidate of the form XYZ here, and we have the candidate of the form YZ here, and there is exactly 1 cell in common between these 2 cells. So which means that we can eliminate this common candidate from the cell which sees all these 3 cells. I mean these 3 cells, row 5 column 1, row 9 column 1 and row 9 column 3. So in this case, these are the 2 cells which see all the 3 cells. So basically you can eliminate the 7 from here and put a 3. So if you face this situation in actual classic Sudoku, you can immediately place the 3 here. You need not guess or anything. So if you have a 7 here, what happens? Let us look at the contradiction, because that will help us assure ourselves that this is the way it works. So if you have a 7 here, this becomes a 2, this becomes a 4. So what will you have here? Nothing, right? So this is how an XYZ wing works. So when you have such possibilities, you can immediately write the 3 here. Now we will move on to the third and the final example. I have distributed the digits a little bit far away so that our viewers are not restricted to seeing boxes which are very adjacent or close together. It can occur in 2 different boxes, I said, but those boxes need not be adjacent. They can also be far away like this. So can you guess what elimination we can make here? So we have a XY candidate here. We have the XYZ in the hinge candidate. A hinge is nothing but which is like away from these cells, right? So, and we have a 1,6 candidate here which is common between these cells, right? So now the cells which see, just a moment. Sorry guys, this example is slightly wrong. So I'll make it a little bit correct. So let me put a 5,6 here. Let me put a 1,5,6 here and a 1,6 here. Yeah, I think this should work. So when you have such format, we have now the hinge candidate which is seeing both of these cells, right? In the earlier example, the hinge candidate were not seeing both the cells, so that is important. So we have a hinge candidate with 3 possibilities, and we have 2 other candidates, right, which is having exactly 1 common cell between them. The 6 is common between these cells. Now we can eliminate the common candidate between the cells which see all of these 3 cells, right? So from these cells you can eliminate the 6, right? Because if you have a 6 in any of these cells, right? You are going to get a contradiction. Let us see that. So if you have a 6 here, which means this will be a 1 and this will be a 5, and now you can't have a 1 5 6 here. And similarly, if you have a 6 here, you get a 1 here, you have a 5 here, and you still can't have any possibility in this cell. So this is how an XYZ wing works. We'll go to the first example now. I mean the grid, actual grid. So when you again repeat what I said, you need to basically have three different possibilities in cells which are spread out across two different boxes. The boxes need not be adjacent, as I showed you in the third example, and you need to have an apex candidate or hinge candidate which sees two other cells, and those two other cells must have exactly one candidate in common between them. When that is the case, you can remove the common candidate from the cells which see all of these three cells, right? So we'll move to the actual grid now. So I'll ask our viewers to pause here and try to find the XYZ wing that I explained to you guys in the video. So if you are able to spot it, it is good. If you are not, you can still practice and get better. No worries at all. So I'll pause maybe for 2 seconds. Okay, so the XYZ wing is happening in these cells here. This cell, and this cell. We have an XY cell here, we have an XYZ here, and we have a YZ here. So which means that, and there is one digit common between these two cells. One is exactly common between these two cells, which means that the cells which see all of these three cells, that is this and this, I'll use a yellow color. So these two cells can't contain a 1, because if any of these two cells contain a 1, you get a 2 here, you get a 5 here, and because of the 1 here, you cannot have any digit here. So which means that we can eliminate the 1 from this candidate, right? From this cell, right? So you can't have a 1 there. Beautiful. This elimination of 1 gives us a 1 here, because we got a 3-4 pair here, which gives us a 1 here. Beautiful, beautiful logic, right? So this one gives a 2 here, this 2 gives a 4 here, a 3 here. We have completed column 6 now. So these two cells must be 3, 4, right? They can't contain a 3 anymore. 3, 4, 6, 1, 5, 7. Remaining are 2, 8, 9. So this is 8 or 9. This is 2 or 8, and this is 2, 8 or 9. And now you can eliminate the 2 from here. This is 1 or 5, right? And 4 is here, so you can eliminate the 4. This is 1 or 2. You have 3, 7, 8, 5, 6, 9 here. So which means these three cells must be 1, 2, 4. We can pencil mark them. You have a 4 here. So this must be a 3 and this must be a 4. So this is not a 4. This is 2, 3. And 3 is here. So this is a 2. And this is a 1. This is a 9. This is a 2. And this 9 gives an 8 here. And this 2 gives a 2 here, a 9 here. And this 8 gives a 6 and an 8 here. And this will be a 3, this will be a 6. Just because of eliminating this 1 using the XYZ wing, you're able to see we are getting many digits, a flurry of digits, and the Sudokus become suddenly very easier. A beautiful Sudoku which was created by Kumar for us to explain this wonderful technique called XYZ wing. So, and 6 is here, so these two cells must be 3, 7. This is just regulation stuff. Anybody can finish the Sudoku now. You have a 1 here, so this is a 1, this is a 5, 4, 8, 9, 1, 2, 3, 5. So remaining are 6, 7, 1, 6, 7, 2, 8, 9. So 3 is here, so this is a 3, and these two cells must be 4, 5, right? And along column 8, 2, 4, 8, 3, 6, and 7. So remaining are 1, 5, 9. You have 5, 9 here. So this is a 1, this is a 2, this is a 1, this is a 2, this is a 2, and this must be 1, 4. Beautiful Sudoku, guys. Amazing classic, really. And this 4 gives us a 4 here. This gives us a 3 here. And this 3 gives us a 7 here, a 3 here. This 7 gives us a 7 and 6 here. And this must be a 7. And 3, 4, 5, 8, 2, 7, 9. Remaining are 1, 6. This 6 gives us a 6 here, a 1 here, a 1 here, a 4 here, a 4 here, a 5 here, and a 5 here, and a 9 here, right? Let me check if the classic is correct. Yeah, it seems correct. So because of this XYZ wing that we used in these three cells, the very hard classic became easier just like that. So I hope you understood this technique of how the XYZ wing works. This is basically the pattern that you need to look for across either two adjacent boxes or different boxes. So I hope you guys enjoyed watching me solve this video, and with the help of the three examples, I hope our viewers clearly understood how an XYZ wing works. So please let us know your thoughts in comments. How was the video? We'll be delighted to hear from you and hope to see you all soon. Thank you.